All right, for number 37, we're asked to find the end behavior of this function. C of x equals 5x squared over x cubed plus 2x plus 1. All right, so to do this, to find the end behavior, what we're asking for is the limit as x approaches infinity of this function. So we want to figure out what the limit as x approaches infinity is of this function. And also what the limit is as x approaches negative infinity. So let's put that on here too. The limit as x approaches negative infinity. So that's going to give us, this is going to give us our right end behavior. What's happening as x goes to the right. And this is going to give us our left end behavior. What happens when x is going to the left, when x is getting very negative. All right. So the way that we can think about this, it says to just think about it logically and figure out what the end behavior is going to be. So let's think about what happens if we plug in some really big numbers for x. So we can't plug in infinity, obviously, because infinity is not a number, but we can plug in a really big number. Let's plug in 1,000,000. So if we plugged in 1,000,000, we get C of 1,000,000 is going to equal, well, 1,000,000 squared is 1,000,000,000 times 5 is 5 trillion. And then on the bottom, we've got 1,000,000 cubed. Well, that's going to be 1 quintillion. So we've got 1 and there's some other stuff here. There's 2,000,001 that we'd add on to there. But 2,000,001, I mean, that's so small that that we really don't even have to consider that at all. Let's leave these as just zeros here, because it'll make it easier for us when we think about what this really means. So 5 trillion over 1 quintillion. So 5 trillion is a lot. A trillion is a big number, but it's not anything compared to a quintillion. If you were a quintillionaire, and $5 trillion to you would be like $5 to a millionaire. And let's show that. Let's cancel some of these things out. Let's divide. So these zeros represent thousands, right? So if we divided 1,000 by 1,000, that just divides to 1. So we can get rid of that set of zeros. We can get rid of that set of zeros. All of these are dividing to 1. And what we're left with is 5 divided by 1,000,000. So that's going to be a really small number, 5 divided by 1,000,000. And so we can imagine that with all of these numbers, since x is squared up here and it's cubed on the bottom, no matter how big the number is on the top, the number on the bottom is going to be much bigger as the numbers get bigger that we're plugging in for x. So this is going to go to 0. So as the limit as x approaches infinity of this function is going to be 0. We're just getting closer and closer to 0 the bigger these numbers get. And so we say the limit is equal to 0. And then on the other side, if we plugged in negative numbers, well, that's gonna it's gonna be the same thing. I mean, we'll have negatives, but they're gonna be getting closer and closer to 0 as well. And so we'll say that the end behavior is 0 in both directions. So we can just give me this, that the limit as x approaches infinity of this function is 0, and the same thing for the limit as x approaches negative infinity. What it'll end up looking something like this and like this. But you can see that as we go to the right, x is approaching 0. As we go to the left, x is approaching 0.